Hello everyone, in today's video we will be revising EAS, Electrophilic Aromatic Substitution. And the very first question to start with is like you need to figure it out like what will be the major product over here. So when Br2Fe is treated. So if I talk about like Br2Fe, then it's a halogenation reaction, right? And so halogenation is nothing but it's like X2 in the presence of a Lewis acid, or you can have metal also, Fe. What basically X2 will combine with Fe to give FeX3. So in this very case, you will be having your attacking electrophile as Br plus that you know. And the thing which is important with respect to the compound is the directive nature of all these groups. If you have an idea, then it becomes relatively easy. Since you have a attacking electrophile, which means it will be attacking onto the ring which is having a high electron density. So if I talk about things and all with respect to CH3, then we know that it will be giving electrons. So that will not be the deciding factor over here in this case. You have NH C double bond O. So if I talk about this carbon, then it is directly associated with this ring. And since there is a C double bond O, so it will be taking electrons away from this ring. Whereas if I talk about like NH, since nitrogen is having a lone pair, so it will be giving electrons in the ring. We understand like if you will have aniline over here, the lone pair on nitrogen is 100% going inside the ring, so that will cause the compound to be like acting as highly activating, or the group itself will be called as highly activating group. Whereas if you have something like NHC double bond O, over here you know that some part of electron density is going in the ring and some part of electron density is going to the right side also, so that will cause it to be like moderately activating. But overall, yeah, if you have nitrogen, so this ring will be more activating, and if this ring and all will be more activating, then Br plus will be attacking at that ring only. Now in this ring you have got two probable sites. One is this one, another one is this one. So you do have to also take care of the steric factor. And of course, if you are governing it onto the basis of NH, then this will be like meta directing. So that will not be targeted, but with respect to methyl group, it will be like ortho directing. So things and all are decided on the basis of this group only. So the behavior of that group in the ring only will be the deciding factor, and there is only one side, that is parasite with respect to NH. So the right answer for this one will be like Bombay. Now, based on the same segment, it was like in the previous question, it was halogenation. So now in this question, there is nitration. Over here, it has been told like it is mononitrations. And it becomes relatively easy for you now. But what you can expect in exam, they will be asking you like what is the major product only for the given reaction. This part will not be given to you. So over here, if I talk about nitration, then you understand like concentrate H2SO4 with HNO3 is like called as nitrating mixture. But you can have different reagents also that will come into picture. It's not like every time you will have HNO3 plus concentrate H2SO4. You can have dilute HNO3 also. You can have concentrate HNO3 also. You can have something in the form of salt like NO2BF4. Over here, you know that it's a ready-made electrophile you will have. You can have NO2 ClO4 also. Over here also you will be finding that there is a ready-made electrophile which is there. So again, if you have to answer it, then you have to see the behavior of this. Since I've already discussed it in the case of halogenation, over here this C double bond O is directly there with this ring, so that will cause the electron density to be less. Whereas for NH nitrogen lone pair, it will be giving electrons in the ring. So if it will be giving electrons in the ring, then high electron density will be there at ortho and para, right? And since you have got NO2 plus, so NO2 plus will be targeting ortho and para. So unless until specified, you have to mark it to to be like para only as your major answer. In many cases it will not be specified, but in many cases you have to only assume that key para will be the major answer, not ortho. There are only some 5% in complete organic where you will be finding like ortho is a major answer. So apart from that, you can mark straight away para as your answer. Now the third segment is again from halogenation segment only. You have got aqueous bromine. So what's more important over here is this 3 equivalence. Although I have mentioned 3 equivalence, which means you understand like there will have 3 bromine attached. But let's suppose this is not mentioned, because in exams you will be finding like it will not be mentioned. Now you have aqueous bromine, which basically means bromine water, right? है ना? So if you have bromine water, then you have to figure it out. Over here is like you will have bromine that will be coming and being attached into the ring. With respect to the behavior of OH, or, we know that it will be giving electrons. But with respect to SO3H, we know that it will be taking electrons. So since bromine is coming, so you have to see the behavior of OH only as the predominating one. And since you have aqueous, which means what will happen over here is, if you are only restricting yourself with respect to putting one Br over here, because that is the only site which is free. But over here you have to understand one thing is like you have OH and you have H2O. So what it will be doing is like H2O will be taking the proton from oxygen, and if it takes, then the oxygen which was over here giving electrons in the ring, as well as now if I talk about like this, because of the single bond, it is like having minus I, so it is having plus R and minus I. So because of minus I, there will have some electron density lesser compared to the second one, because for the second one there is like O minus, and O minus will be giving it, so the ring and all becomes like highly activating. So in cases like where you will have ring to be like highly activating, then in that case, whatsoever be the sites which are available, onto those sites you have to make the attack of Br. So this site is also free, so you will have Br to be attached over here. Now since you have got aqueous medium, so bromine in like polar protic solvent, what will happen is, because of aqueous, over here SO3H is there, so there will have desulfonation that will also be taking place parallelly. And if there will have desulfonation that will be taking place simultaneously, then what will happen, this SO3H or this carbon valency will be free, and over there also Br will go and combine. So it's the right answer. You will have it to be like Br at all the 3 sites, which is very, very important. And I just take care of this in exams. Now the next one is like you need to find again the major product. So in this case, if you can see, it's nothing but Friedel-Crafts acylation. Over here, what students generally believe is, since there is oxygen, so it will have lone pair. So of course, oxygen will be giving its lone pair, okay, to the one which is deficient. And over here, you can find like there is Cl, so that Cl will have a leaving ability. So if that Cl will have a leaving ability, then lone pair on oxygen will be giving it. You know? So you will have carbon, have CH2, and you have C double bond OCl. The next part and all that you have to figure it out over here is, since you have got AlCl3 anhydrous, so what this Cl will do is like it will be associated with this aluminium, it's a Lewis acid, and that will cause to be like forming a acyl carbocation, right? So if I have to write it, then you will have OMe, this is like oxygen CH2, and there will have C double bond O plus. And now what you have to see is, in this case, you know that OMe will support the electrons in the ring. Similarly, the thing and all will be there for oxygen also. So if I have to see the sense of polarization, it will be moving in this direction. So because of that, this carbon will bear a negative charge. And since there is internally you have got carbon having a positive charge, so that will combine with each other. So basically you will be getting a 6-membered ring. And after getting a 6-membered ring, you will be finding that something like that will appear. And now to regain aromaticity, H plus will be out. And if H plus will be out, then you will have this as your answer. I think I misses out double bond O. Many people will think it to be like AlCl3 is there. So AlCl3, first it will be forming a acyl carbocation. And now acyl carbocation will go and attack onto the ring. So if I talk about like OMe, electron density will be high at this very place. And if I talk with respect to OH, it will be high at also these very two locations only. Which means if you have to answer it, okay, you have to take care of the sites which is available. So if you are making that acyl carbocation to be targeted over here first, then TK, it makes sense. But at that time, you will have this Cl that will be left out. And with AlCl3, it will be combining and you will have plus over here. And accordingly, there will have a 6-membered ring from this carbon. But again, as I have told over here, it's a two-step process. So if it's a two-step process, then you have to think it like that. You don't have to think altogether is like first and second will be combining together and they will be furnishing the acyl carbocation and that will be attacking. Now for this one, like if you can see over here, you have oxygen which is having a lone pair and you have got C double bonds OCl. So this oxygen will be targeting onto this carbonyl segment because it is electron deficient. And this O minus next step, what it will be doing is it will be kicking out the leaving group which is Cl. So that will cause it to be like you will have O minus Cl. There is like CH2 and there is like CH2OH. So over here O minus will give electron and Cl will be out. Accordingly, you will have a double bond O, C double bond O. And you have CH2, CH2OH. This one is like OMe. This is a dehydrating agent, so you will be protonating this and there will be a plus that will come. So this exactly resembles to that of the previous problem that I have given. Only difference is like C double bond O. Over there it was over here. And now in this case, it is over here. So I believe that this session would have increased your level in EAS. We'll meet again in the next videos with some different topic. Till then, take care. Bye-bye.